Alright, in this video we're going to be calculating the y-intercept of a particular line equation based on what points it is going to go through. And then we're going to use the same logic, but we're going to compare a line that is passing through 2 points, and then we're going to calculate both the gradient and the y-intercept just from that information. So to begin with, we have this question here that asks us just to find the y-intercept. And we're actually given the equation of the line. The only thing that we need to find is that b, which is the y-intercept. So in order to do that, we need to know that it tells us a point, a set of coordinates that this line is going through. So one thing we could do to find b is substitute those coordinates into x and y, and that way we can rearrange the equation to find the value of b. So for example, if we put 3 into x here, then y must be equal to 4. And then the equation is going to look like this. And now what we can do is we can simply rearrange it so that b is going to become 4 minus 3, which is going to be 1. So that's going to be the y-intercept, and then we can rewrite this equation as y equals to x plus 1. And we can always check that that's the case, because if we plug in the values again, if we put 3 into x here, that becomes 3 plus 1, which is 4, and that's correct. Now for the second question here, we're also given the equation of the line, but this one is going to pass through a different point. So we're going to apply the same logic again. We're going to put this value minus 2 into x, and then y is going to be equal to 3. So now we have 3 equals to minus 6 plus b. And now if we rearrange the equation, we find that b is going to be equal to 3 plus 6, which is 9. And so the equation of the line becomes 3x plus 9. And you can always check by just substituting the values into the equation again. Now for this question here, once again we're given a different point, so let's see what we get. So we're going to have minus 2. And for y we just have 4, so that's going to be plus b. This is going to become plus 2. Therefore, we're going to have b equals to 4 minus 2, which is 2. So the equation of the line should be minus x plus 2. And we can check that because if we place this in here, that becomes positive 2 plus 2, and then that gives us 4. Now in the next set of questions, what we're going to do is we're given 2 points that lie on the line, but we're not given any other information. We don't know what the gradient is, we don't know what the equation of the line is, so we actually need to find all that information just from those 2 points. So the first thing we know, so the general equation of a line has 2 components. It has a gradient m, and it has a y-intercept b. To find the intercept b, we need to know what the gradient is. Otherwise, just substituting values into x and y would just give us another unknown value. So we need to find what the gradient is first. And as we have done before, remember that in order to find the gradient from 2 points, all you need to do is you subtract the y coordinates, so that's going to be 10 minus 6. And then you subtract the x coordinates from the bottom. So now we're going to have 4 divided by 2, which is 2. So we already found the gradient. And now what we can do with that is we can actually just write the equation y equals to 2x plus b. So now you see that we have a similar situation to the previous question where we were given the equation but not the y-intercept. And now all we need to do to find b is just sub in a set of values that are given here. So for example, since both points are actually on the line, we can sub in any values that we want. So we can either choose this set of coordinates or that set of coordinates. We will get the same answer. I'm going to choose these ones because they're the smaller numbers. So we're going to have 2 times 6, and then actually that should be 2 times 2. Here we should have 6 for y plus b. So this becomes 6 equals to 4 plus b. Therefore b is going to be equal to 2, and the equation of the line is going to be 2x plus 2. And we can check by plugging in values there. So for example, this one, 2 times 2 is 4 plus 2 is 6, and that's correct. And now we're going to do the same for these 2 other questions. So first of all, find the gradient. Let's have minus 2 minus 6 on the top. and then we have 5 minus minus 3. So we have minus 8 divided by 8, and that's going to be minus 1. So now we can write the equation y equals to minus x plus b. And here what we're going to do is we're going to have, we can select the set of points. So let's try this one, for example. So we're going to put 5 into x and then minus 2 into y. So that means that b is going to become minus 2 plus 5, which is 3. So the equation of the line becomes minus x plus 5, plus 3 actually, should be plus 3. And now we can check that this is indeed correct. So let's, for example, put 5 into x here. Minus 5 plus 3, which is equal to minus 2. And if you notice, that's exactly what we needed. So it is the correct equation. And now for this one, we're going to find the gradient again. So m equals to minus 1 minus 7 divided by 3 minus 1. At the top we have minus 8, and at the bottom we have 2. So this becomes minus 4. So the equation is minus 4x plus b. Now we're going to sub in some values. So let's choose this one. Put 1 into x. So that's 4 plus b. And then y should be 7. So now b is going to be 11. The equation can be written as minus 4x plus 11. And we can check. So if we put 1 in here, that becomes minus 4 plus 11 is 7. And if we put 3 in here, that becomes minus 4 times 3 is minus 12, plus 11 is minus 1. And that's it. That's how you find the equation of a line based just on 2 points that are lying on it.